Welcome back, doing a little bit of revision for my GE, specifically circle theorems, finding missing angles using circle theorems. Let's jump straight into it. Here I've got circle, pair of lines that intersect, opposite angles, equal, y equals 84 degrees. Down here, angle X is in the same segment, the angle comes from the same chord, almost, like that. So that this angle here is the same as this angle here, 36 degrees. And then over here, angle Z has got to be the third angle in a triangle to make all three add up to 180. 84 plus 36 is 120, so Z has got to be 60 to combine with all three to make 180. So far, so good. Next question. A circle with three lines coming out from the center, all marked with this dash. We know that means that they're all the same length, but we could tell that anyway because this is the center of a circle, meaning that these three lines are all radii. Of course they're the same length. Now, these lines form a pair here of isosceles triangles. You usually see isosceles triangles in this kind of orientation, all right, where the different side length is at the bottom and then the two that are the same face upwards like this. In this case, they're upside down, but that doesn't matter. They're still the same. They still behave in the same way. Angle A is going to be 49 degrees, the same as this angle here, and angle C is going to be 82, the angle that adds up with the other two to make 180. Angle E here, got a straight line, it's the angle that combines with angle C, 82 degrees, to make 180. Yeah, we know that two angles on a straight line have to add up to make 180, so that's 98 degrees. And then this larger triangle here, another upside down isosceles, meaning that these two angles are the same size. So if angle E is 98, angle B and angle D have got to combine together to make 82, because that's what adds to 98 to make 180. And because they're the same size, I can effectively half 82 to make 41. They're each 41 degrees. We're making good progress here. Here we've got something that looks a bit like an arrowhead, but that we do not call an arrowhead. We say that the angle at the center is double the angle at the circumference. Got to remember those wordings. This angle is therefore 48 because it is half of 96. And then this angle in the middle is going to be the difference between 96 and 360 angles around a point. So that's 264. Over here, we have a similar array here. This is still going to be this angle here. Angle B is going to be double angle 53, 106. But we've also got another section added on to it here. Remember this theorem. Angle A and angle 53 degrees are opposite angles in a cyclic quadrilateral. Remember that wording? These two add up to 180. So 127 has got to be the value of A, because 127 plus 53 is 180. Now, as for this last angle C here, there's multiple ways you could find this, but I'm going to find it by finding this reflex angle here in a similar way as I did for this question. 254 is the difference between angle B and 360. And then, because this is a quadrilateral, all four of these angles add up to make 360. 254 plus 32 plus 53 makes 339. The angle that I add onto that to make 360 is 21. That'll do for now. I might do a few more in a few minutes, but hopefully that'll help you understand the application of circle theorems in a bit more detail.